Welcome to qnawire.
In this question, we are looking at a diffraction of the proton and the alpha particle through a circular aperture. So for a circular aperture, where the diffraction limit, or the angle in which we get the first dark ring, is given as sine theta equals to 1.22 lambda over d. Right, this is often referred to as the diffraction limit for a circular aperture, right? Where d is the diameter of the ring, of the hole, right? But of course, we don't know what is the diameter of this aperture, so we will need to somehow get rid of it, right? And we can do that because we are using the same hole. So taking the angle of the proton, and we divide this from the angle from the alpha particle, right? What we get is 1.22 lambda of the alpha, right? The wavelength of the alpha particle divided by 1.22 wavelength of the proton. So now we just have a simple ratio between the wavelengths and the diameter of the hole is gone, right? So very simple to get the wavelength. This is related to the de Broglie's wavelength, right? Goes to h over the momentum, right? Where momentum is related to the kinetic energy, right? Where p squared over 2m is given as kinetic energy. Now furthermore, the kinetic energy is related to the acceleration of our particle, right? Because it depends on the charge and the potential difference, right? And we're given that this potential difference is applied to be the same for both these particles. So basically, relating everything together, right? P squared over 2m is equals to q times v. Therefore, h over p equals to h over square root of 2mq times v. And if we were to put it into this expression, we get is the constant, which is h, will be gone. So we're left with only square root of 2p qp times v over square root of alpha times v. Right, they are flipped because this is inverse, right? This is 1 over the square root, so the proton one will go to the top, alpha one will remain at the bottom. Right, so v is the same once again, so we can get rid of that. So we have the constant 2, which we can remove. So we're left with only square root of mp qp over m alpha q alpha. Now, what we want is the angle for the alpha particle, right? We know the angle of the proton is 15 degrees. So sine of angle of the alpha particle be sine 15 degrees multiplied by this factor. So mass of the proton divided by mass of the alpha particle, right, is approximately about 4 times, right? Since alpha particle is about 4 times as heavy, so this would be about 1 over 4. The charge for the proton is about twice the charge of the alpha particle is about twice. So therefore the proton over here, this will be 1/2, and this will, in total, we just need to take sine 15 degrees divided by square root of 8. And after dividing that, we take sine inverse. And sine inverse of this entire expression, and we should get the alpha particle angle to be about 5.3 degrees.